Which of the following is the most abundant state of matter that is found in the universe? Option A, solid. Option B, liquid. Option C, gas. And option D, plasma. Now let's discuss the answer. State of matter. What do you understand by matter first? Matter is everything in the universe that has mass and that occupies space. We all know that mass implies an amount of substance with which an object is made of. All the matter is made of atoms. Atoms are structured into nucleus and the outer part. The nucleus consists of protons and neutrons. Protons has positive charge and neutrons do not have any charge. And the outer part of the nucleus, we have electrons orbiting or roaming around, which has got negative charge. Now, what do we understand by state of matter? Generally, we describe the state of matter based on certain qualities the matter exhibits and how we feel. In the sense, by touching or by seeing certain qualities. For example, we take water, which is liquid, and the very same water is condensed, and if it is in ice form, we call it as solid. If we heat the water, it becomes water vapor, the gas state. So here we can find that a solid has got a fixed volume and fixed shape. Liquid has got volume. However, it doesn't have the fixed shape. It takes the shape of the container. Gas, if a matter is in the gaseous state, it keeps changing the shape and the volume. There is no fixed shape and volume for gas. And the plasma is the fourth state of matter. Generally, we consider solid, liquid, gas, and plasma as four fundamental states of matter. The only difference between gas and plasma is that gas is electrically neutral. It doesn't have any charge. Plasma has charged particles. So plasma is not electrically neutral. Apart from these four states of matter, we do have such as Bose-Einstein condensate, time crystal, and the others. They are not occurred naturally in the universe. They are synthesized in the laboratory. So they are artificial states of matter. How is gas converted to plasma? Let us see first how a solid is converted to liquid. If there is the ice cube, if we heat, it is converted into water. The very same water, if we heat, it is converted into gas. At this stage, the hydrogen atoms and oxygen atoms, they get separated. If we further heat the gas, then what happens is these atoms, they disintegrate or they get ionized. What is ionization? Ionization is a process by which electrically neutral atoms or molecules get converted to electrically charged atoms or molecules. Here, if we heat further the gas, the outer shell, the electrons which are there in the atoms, they are stripped off. When they are stripped off, that is, if an atom loses an electron, generally in an atom we have equal amount of protons and electrons. So protons have positive charge, electrons have negative charge. So they are not electrically conductive as they're equal. If one electron is stripped, if the atom loses one electron, automatically this atom gets positively charged. When it is positively charged, we call this, if there is some quantity of matter ionized, then we call that partially ionized plasma. See, generally the gas is converted into plasma in two ways. One is by creating huge voltage difference between 2 points, the gas is converted into plasma, and the other is overheating. When you superheat the gas, it is converted into plasma. Let us see the difference between the partial ionized plasma and fully ionized plasma. Generally, to call that an atom ionized, at least one electron must be stripped. One electron must be taken away from the atom. One electron must be removed from the atom. It can be more than one electron. To call a matter a plasma, at least there should be some portion of matter ionized. We are not sure yet what is the percentage of matter that should be ionized to call it as a plasma. Yes, but if there is some matter that is ionized, we call it as a partially ionized plasma. Generally, we don't find the fully ionized plasma. That can be found in stars and in sun. Here, we rarely find the fully ionized plasma on the earth. Probably in the laboratories, it may be created. There are certain things that should be remembered about plasma. Plasma has a very high kinetic energy. Kinetic energy is the energy an object possesses or has because of its motion. And another thing is that the plasma is the most abundant state of matter in the universe. Almost 99% of matter is in the state of plasma. We may not find the state of matter plasma in our earth, but in the universe 99% it is in the state of plasma. This is a very important point to be remembered. And another thing is that plasma is electrically conductive because it has got charged particles. Although it is a rare or an exceptional phenomenon or circumstances to find plasma on the earth, we do have certain examples. In our homes, the plasma TV that we have is one example. The fluorescent bulb is an example of a plasma. And outside the shopping malls, shops, we have neon signboards. There, what is inside is the plasma. This principle is used, and by using this principle, neon signboards are made. And we do have the naturally also we find it is in lightning. We find plasma, that's ions are created through electricity passing, and the light is emitted and we see the light. There we find the plasma. And another good example is aurora borealis, aurora australis. That's the northern lights that we see. See, we have solar flares, coronal mass ejection coming and hitting the magnetosphere, and then that is moved to the poles. Understand? There we find the light. This coronal mass, solar flares, they are one type of plasma, and they come here, they interact. Another kind of plasma is formed near the poles. Okay, this is one of the best natural example we have. This is northern lights. Okay, and another important feature is that it behaves like fluid, and it also acts as like electrically conductive. So if you have to really understand this concept, probably we have to use the principles of studying fluid as well as the Maxwell's equations, that the content or the principles related to conductivity. So probably sometimes we may find it difficult to understand in depth. And just to have the quick recap of the plasma, see, if you take an ice cube, initially it is in a solid state. If we heat, it is converted into water, that is liquid state. If we heat further, it's converted into gas, where hydrogen and oxygen are disintegrated. If we further heat, then it is changed into plasma. If you remember, the sun and all our stars are in fact superheated plasma balls. As we have a lot of hydrogen, the hydrogen doesn't have neutron, and you have only proton and electron, and you will have a pool of electrons and nucleus. It's a pool of plasma there. This is in general a few points about plasma. Thank you.